Okay, so hopefully in the last video you found and you were able to follow along with the rule that we established from earlier. Now we're going to do a little bit more of a concrete example where instead of just having a value of a, now we have a value of 2. Now, when you are differentiating these types of functions, it's very much the same as we have done before. What we're finding is we're using the chain rule and we're finding the derivative with respect to x using the chain rule. So I encourage you to pause the video from here and try to solve the question yourselves first. And then in a couple of seconds or minutes, we'll go through it together. Okay, so hopefully you've paused the video and had a crack at solving this one yourself. So now what I'm going to do here for this question is relatively simple. So I'm going to take a couple steps that are not really necessary at this point, but I just want to highlight that are going to be useful for functions that become a little bit more complicated. So I'm going to use my chain rule. Recall that according to your chain rule, if you find your derivative of y with respect to x, that is just the same as saying dy by du times du dx, just like that. So what we're going to do is make a substitution for u, find the derivative of u with respect to x, and then we are going to derive dy by du. So in this case, what we're going to say is let u equal to just x. And in our case then, well, that means du dx is equal to 1. Okay, that's all good and fine. That means our function of y is equal to 2 to the power u. And you'll see why my method at the moment here is a little bit overkill. It takes a few extra steps because we're not really changing anything. But you'll see why this is useful in a minute when we're doing a more difficult example. So from here, we're going to find our derivative of y with respect to u. Recall the template that we had worked out earlier. Now, you don't need to necessarily remember this. If you can do your algebra well, then you can always just derive this yourself. So, but anyway, we've got some function, we've got some derivative of f with respect to x. That means all we need to do here really is plug in values. Our value of a is equal to 2. Our value of x is equal to u. So the whole thing here, dy by du, is equal to a to the x, so in our case that's 2 to the power u, times the natural log of 2. And then all of this is basically just equal to 2 to the power x natural log 2. And then from here, dy by dx is equal to dy by du, which is all of this stuff here. So that's 2 to the power x natural log 2 times du by dx, what we found earlier, so times 1. So all of this is 2 to the power of x natural log 2. And we're done with this particular example. Now from here, I encourage you to try another example. This time, the example we're looking at is this one here. So this one here is a little bit harder to do without the chain rule, so I highly, highly encourage you to use the chain rule in this case. Let's say that we have a function g of x. And that function g of x is equal to 3 to the power of 2x squared. Now, have a go at trying to solve this problem here just for yourselves at the moment, and we'll come back to it in a couple of seconds or minutes. Now, I hope that you've had a go at this question yourselves. So, in this case, what do we have? Well, we have, let me just, I think I still have that saved. So let me put that back over here just for a moment so it's visible. So now you can see we're going to need to use the chain rule. There's no way around it, right? So we are going to let some function u be equal to 2x squared. That means du dx is equal to 4x, just like that. Okay, fair enough. That means that my function g is equal to 3 to the power u. Now, I need to find dg du, which is equal to what? Well, again, using our rule that we established earlier, that is just our value 3 to the power u times the natural log of a. So let's go ahead and plug those numbers in. So that's, whoops. So that's 3 to the power u times the natural log of 3, which is, of course, equal to 3 to the power of 2x squared natural log 3. And now we're going to need to put the chain rule together. So that's dy, sorry, not dy, we're working with our function g, dg dx is equal to what? dg du, that's 3 to the power of 2x squared times the natural log of 3 times du dx over here. So times 4x, just like that. And the whole thing you can write as, well, you can write this in a number of ways. Just to simplify things for myself, I like to write it like this. 4x times 3 to the power 2x squared times natural log of 3. Now, you obviously don't have to write it in this order. I just like to do it this way. You can even put the 4x in between these two because you're taking this times this, and multiplication has the neat property of being commutative. That means it doesn't really matter what order you multiply things in, you get the same result. All right. I hope that this has helped you, and we'll see you in the next one.